In this example, self-bias configuration with bypass RS is used to show how high frequency response can be obtained. The configuration of self-bias can be drawn back as like this. Okay, this is the AC equivalent circuit, and we can divide into two areas. The left side is the input part, and then the right side is the output part. So the high frequency response will be examined from the input side, and we get the FHI, and the output side is FHout. Now we examine one by one. We start with the FH in first at the input side. Okay. Let me see this figure. Okay, we know that this capacitor that contain C in contain the CW in, and then CGS and CMI Miller effect, and the CMI for the input part is 1 minus voltage gain and multiply with CF. Now we know that from the original circuit, the CF is CGD. Okay, so this is the overall input capacitance. C in equal to CW in plus CGS plus CM in. After we calculate value of C in, now we can calculate the frequency response at the input side. But first, we must calculate the RTH in. Okay, you can see the RTH in at this side. Okay, by looking from C in, the total input impedance, the RTH in, can be obtained by R6 parallel with RG. Can you see here? R6 now is parallel with RG. Hence, the higher cut-off frequency for input is FH in equal to 1 over 2 pi RTH in CI in. So, from the previous slide, we calculate the C in, and just now we calculate the impedance here. So, we can get this value for cut-off frequency at the input part. Now we want to find high frequency response at output side. So we take a look at the AC equivalent circuit for the output side. Can you see this capacitor? This is C out. So actually inside C out, okay, in details is CDS, CW out, and CM out. Okay. So due to the effect between input and output terminal of the device known as Miller effect capacitance, now the CGD become CM out equal to 1 minus 1 over voltage gain, and then multiply with CF. So CF here we replace with the CGD. Then the overall output capacitance is C out. Here, C out equal to CW out, CDS plus with CM out. Now we can calculate high frequency response at output side by using this equation 1 over 2 pi RC. Okay. Before that, we have to calculate the impedance, output impedance using Thevenin method, the RTH. Now, RTH equal to RD parallel with RD and parallel with RL. Then, we insert this value into the equation, okay, together with the C out that we calculate earlier. Then, we get this equation, FH out equal to 1 over 2 pi RTH out, C out. There are two high frequency response as discussed previously, FH in and FH out. So for the whole system, the high frequency response will be the smallest value from both high frequency value.